My name is Nancy Silva, and in this video I will present the key finding of my research that have the title of A Comprehensive Analysis of the Critical Blockchain Attacks and Mitigation Strategies in Decentralized Networks. So first of all, in the beginning of this project, we need to remember that blockchain is described as a secure and immutable technology, that it is, but in the real world incidents show that the security it not only depends in the cryptography, but also on other terms, important terms inside of the blockchain, that is the governance, the decentralization, and the human behavior. So in this presentation, I will freely explain the fundamental concepts, analysis the most critical attacks that can affect the blockchain network, compare their impacts on different consensus mechanisms, and finally provide security recommendation based on my findings inside of my research. Before analyzing the data, it's important for us to understand how blockchains work. First, blockchain is a distributed ledger composed for blocks that are linked with cryptography. It removes the need of central authorities using the consensus mechanisms, such as proof of work, that is based on solving the cryptography puzzle, the second proof of stake, that based of the amount of token that a validator can hold, and the third one, the delegate of proof of stake, that the validator are selected by the whole community. Each of these mechanisms has its own strengths and its own weaknesses, and it is central for us to understand it, because this gives us the opportunity to know why the attacks succeed in this kind of environment. Right now, we are going to understand the different security attacks inside the blockchain. The first one has the name of 51% attack. This happens when the group of person of the hacker controls more than the half of the domain. This gives the opportunity to write blocks and to reverse transaction. But how does it work inside of a blockchain that is supposed to be decentralized? Well, this happens because in the real world, pools and large stakeholders create the power concentration that, well, given the opportunity to this kind of attack happens. And one case, important case, is in 2019 inside of Ethereum Classic that suffers the measure of 51% attack, resulting in about 1.1 million stolen inside of this. That have the name of double spending. This is happened when the attacker, the hacker, use the same cryptocurrency twice. This works because the attacker first send a legitimate transaction. Second, before this one is confirmed, the attacker create a secret broadcast that will conflict with the transaction, and then in this private chain to grow faster, the network accepts this transaction and invalidate the first transaction. In the real world, this probability it can happen because of lowest network or low gas rates make alternative chains easy to generate and easy to confirm. In one case, it was incident in 2014 that this kind of attack, the double spending, to make the confirmation of the transaction and losing over 450 million in total. The third one that we are going to understand is the civil attack. In this one, it's a little bit more different if we are compared to the other one. Instead of gaining a computing power, the attacker via fakes identities to manipulate the network. This is important, so effective in consensus mechanisms as POS and DPoS, because the identity have influence in the voting and in the block validation. This how it works This is where because in some networks, we know we don't put cost requirements when we are talking about the identities. So that's why it makes more easy to create thousands of fakes participation, given the opportunity to have more voting and more block validation to the person to create this kind of fake identities. As several case, the experiment inside of POS network, they visualize that the fake validator can manipulate the block selection. So in this study, we understand that no any consensus mechanisms are like 100 secure. Like no one of them are perfect. Each of them have his own strength and vulnerability, and the attackers all know that. So that's why it's so important for us as engineers to understand it and how we are going to use it. If we compare like each of the mechanism, we can see that some of them like the POW spend more money, or we can compare it to like the POS that um, all the risk depends usually because of the centralization of delegates inside of this layer. So this is important for us. Like the key is that the security depends more on the decentralization and governance than in the cryptography instead. Based on this analysis, we are going to give us a recommendation that I think it's so important to know and so important to use when we are talking of creating this kind of networks. The first one is the strength of decentralization. As we are talking before, um, we need to insensitive diverse of no participation. Like we can do it with limit mining or stacking concentration in order to us to have a secure network. Because as we say before, like the security, it not only involves the cryptography, instead we need to understand that the centralization and the policy inside of the blockchains have an important point to trying to have a work that is secure. And the second one is adopting hybrid consensus model. This is one of the things that I was thinking about, that if we can combine the different consensus mechanisms in a same network, we can ensure that the hackers more difficult to do a successful attack because how to reduce the disease path for the group of persons to do an attack. So we can combine the POW plus POS or POS plus DPoS to help them to give us the opportunity to ensure the security. The third one is increasing the confirmation of three holes. How we are going to do that? We can slow transaction significantly. That's going to happen, but drastically is going to decrease the double spending risk. That is one important and so used attack it inside of networks in this. So even if it costs us a little bit more, like a lot of a slow transaction, this gives us the opportunity to have more secure. That sometimes we need to, of course, to analyze this kind of possibility, but I think it gives us opportunity to have better solutions. And of course, the last one is improving the governance and the incident response. How we are going to do that? Well, we can create protocols that give us the opportunity to update, to audit, to monitoring the systems that we are creating, and of course, giving um, policies and rules that give us the opportunity to proceed with the most formalized. As a conclusion, in this research, highlight the gap between the theory and the real world implementation of the blockchain. Even as we know, as in theory, like the cryptography and decentralization are perfect, in reality, understand that some different environments can give us like the possibility that networks face in maintaining the decentralization, the governance, and the proper monitoring of the networks. So this is not because of the cryptography, it's not because it's weak, this part, it's because like sometimes like the human impact in this kind of implementations. As we can know, it's important to understand that blockchain security, it must be approached as a continued process and not as a statistic failure. By adapting stronger consensus models, improving the governance, and learning from our past attack that it happened, we can create decentralized networks that can be becoming significantly more resilient in a network that can be always attacked. Every single moment that we are having attackers in a system is an opportunity for us to grow in the different mechanisms in order to have a decentralized networks. Thank you very much for your attention in this project that have the name of comprehensive analysis of the critical blockchain attacks and the mitigation strategies inside of the decentralization networks. My name is Nancy Silva, and see you in the next one.